Similar triangles. Similar triangles have the same characteristics as similar shapes, but there are a set of rules for checking or testing whether two triangles are similar. And any of these possible sets of conditions will work. If two pairs of corresponding angles are equal, then you can say the triangle is similar. This rule is given the AA, or sometimes AAA abbreviation. That's basically saying that three pairs of matching angles are equal. Two is sufficient because, of course, it's a triangle. If you know two of the angles, you can find the third. And so if we use a particular example, if those are 90 and that's 30 degrees, then we'll be able to find the other angle, which will be 60 degrees on each. We know that matching angles are equal, and for triangles, pairs of matching angles being equal, two pairs is enough to tell us that there's three pairs. And so if you've got two pairs of matching angles equal, then these are similar triangles. So if you're asked to show whether two triangles are similar, if you've got two matching angles that are equal, yes, they're similar. That's rule one. If all three sides or pairs of sides are in the same ratio, then your triangles are similar. Now we checked our ratio, scale factor K, so I'll just write our rule. And this is the side rule. So if you're asked why two triangles are similar, if all their three pairs of sides are in equal ratios, you say side, side, side. So an example of this would be these two triangles. It's a very simple example. I'll remember, of course, the short sides are corresponding, the medium sides are corresponding, the long sides are corresponding. Now, if you were asked to show that these are similar, you would check the ratio. That 6 divided by 3 is the same as 8 divided by 4. It's the same as 10 divided by 5. So K, the ratio, equals 2 for all of those. So the side, side, side rule tells you that these are similar. The other third rule is a combination of those. Two pairs of sides are in an equal ratio, and the included angle are equal. Now, what I mean by the included angle is it's the angle included between the two pairs of sides that we're talking about. So this angle is included between side 4 and 5, and it matches this angle included between side 8 and 10. This is the side angle side rule, and by writing it side angle side, we remember that the angle has to be in between the two sides. And I'll do an example with that rule here. Show why triangle ABC is similar to triangle XYZ. So you're checking which of these rules, angle angle, side side side, or side angle side, can be used to prove that these two are similar. We have two sides, and we don't know the third, so it can't be side, side, side. We only know one angle, it can't be angle, angle. But we know two sides and the included angle for each of them, and we can see that the included angle is equal, so that's a pretty good start. So we're showing why this is the case. So we would say, if we were being really perfect about it, angle ACB, so remember how we label an angle, this is ACB, equals angle XZY. But we could just say eventually that these included angles are equal. And we check that these sides are in matching ratio. So, scale factor is copy over original for the large triangle. For the longer side here, 24 divided by 8, that's 3. Copy over original, the medium side there, 21 over 7, that's 3. So my matching sides are in equal ratio and the included angles are equal. So you can say, therefore, side angle side two sides in equal ratio and included angles equal. That's a CL there, sorry. Some questions will just ask you to name the condition and then you don't have to go through proving it. But if they ask you to show why, then you need to show it. If you were using side, 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 you'd show that all three pairs are equal. And if you were using angle, 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 you'd just state that corresponding angles were equal. Now there's a tricky type of question that comes up with similar triangles. Just briefly, we solve our similar triangles questions in the same way as we solve our similar shapes questions. So we find the scale factor and use it to find the unknown side. But there's a type of question that pops up with shadows. And skip this bit if you don't really care about the shadows. But here I've got a short pencil and a long pencil. And if I set those up on my page and grab my torch to get a light source, a bit hard to get that there, you can see that, there we go, the short pencil has a pretty short shadow and the longer pencil has a long shadow. That's pretty obvious. And the angle that the sun or the light source comes down at is the same for both of these. And so actually shadows and the upright thing that casts them make similar triangles. And this is used in forensics all the time to work out how tall people are and things like that, all sorts of bits of information. So while they don't look like it, these are triangles because from the top, of the item to the end of their shadow, from the top of the person to the end of their shadow, we've got triangles. We want to know the height of the person, and they're similar triangles because, assuming the person's standing upright, I've got 90 degrees. Those angles are equal. Two angles are equal. Therefore, we've got similar triangles. So when the whole shadow question comes in, remember the length of the shadow is going to be the base of the triangle, and the length of the object, or the height of the object, is going to be that side of the triangle like that. If you get confused, just redraw the triangles without this whole shadow thing happening. And then we can quite easily find x, because it works the same way as for any similar shape. Find the scale factor k, copy over original. This is the copy, 2.7 over 1.6. So my scale factor here is 1.6875, and usefully we've got 1 here, so x is 1, the side there, times 1.6875, so this person is 1.69 meters tall. So we solve problems in the same way, finding the scale factor, finding the unknown sides.